I will talk about artificial intelligence. This is my background. I do this for about 15 years now. I implement different kind of AI or machine learning models in the industry. I did my PhD in this area, especially in the medical imaging or in general in the medicine. AI in medicine. Some of my papers you can find on Google Scholar or actually in Google at all. If you put my name and then add some of the medical topics like skin cancer, for example, breast cancer, brain cancer, and so on. This is something that I'm now involved in, but not only the research part, I'm also doing it for, let's say, for commercial projects, and this is what I'm doing at the company that I have founded in 2010. Yeah, I know that, 15 years ago, machine learning wasn't so cool like it is now. And this is one of the topics that I would like to cover today because many projects are AI projects are failing. And one of the reasons is actually the hype that is in the back. On the other hand, it's good to have a hype on that, and it's good to see more projects that are developed. Develop models that we develop. That we have so many now compared to what we had, let's say 5-10 years ago. All right, that's all about me. When it comes to my experience, not exactly the scientific one, but let's say the more commercial ones. I do different kind of projects, or my company do for different kind of companies, like Stanford University, for example, or Fiber. Many different ones that I haven't even listed here that I have experience with, and this today talk is actually based on experience, right? It's not partially it's about the theory that is behind the AI models, but actually mostly it's focused on how not to make this kind of projects. I mean, AI projects, how not to fail. So AI in general, maybe not exactly. I will not explain you in general what AI is, but maybe more about the hype that is in the back. You probably heard about terms like AI as the new electricity, AI as the new UI, and this kind of, let's say, slogans or hype texts, right? That are more popular now in the newspapers, let's say, and all the talk about AI that is conquering the humanity. This kind of a science fiction part that is now more and more popular than it was in the past. And on one hand, good. It's more. I mean, AI is sounds a bit more interesting, and there are more companies doing it. But on the other hand, that's also a bad thing because actually, based on some stats from 2019, 40% of AI startups in Europe actually don't use any kind of AI. That's very interesting. I mean, AI, they call themselves AI startups, but they don't use any kind of AI in the back, really. At least not for the core business. So that's important, that actually AI is in many cases used just for the hype, right? Why they do that? Why the startups tell that they are AI startups? That's I mean, when you don't know what's the reason, obviously it's about money. And if you call yourself or try to attract investor, telling, oh, we have some AI in the back, we use AI, we use some machine learning, then in most cases you get from 15 up to 50% more funding than other companies that doesn't tell they use AI, even if it's not true, really. I mean, obviously the true here is a bit more, let's say, fuzzy, because you can use some of the, let's say, machine learning methods. But the question is if it's really something that can be called as an AI startup if you use, for example, a linear regression, right? And based on the Gartner research from 2019, 85% of AI projects fails. I know that actually in general in IT, I mean software development, there are not only AI project failing. I mean all projects failing. I mean many other projects fail. I mean, not only in the group of AI projects, but 85% is quite a huge number. And there are some reasons why there are so many AI projects, why so many AI projects fail. So obviously AI has the let's say use case. There's a wide range of how we can combine AI with different kind of industries. That's something that you heard about many times for sure. And well, I don't want to go deeper in this area. There are so many that actually we have so many use cases. Just to give you some examples, that's something that I did for my PhD. I have developed some algorithms for skin cancer diagnosis. Here you have two cases, one on the left, one on the right, two moles. One is a cancer, the second one is not a cancer. Obviously, the one on the left is a cancer because of the asymmetry and some patterns that are specific for melanoma. And on the right, you have just a mole that might be suspicious, but it's not a cancer. So that's one of the use case. Something that we also did in the company in the past, we work, or we do actually currently as well, is a cooperation with Codete, where we actually use machine learning technique of blockchain to do the image recognition. It's not exactly, I mean, if you put blockchain AI in the Google and try to search, you will probably find something that distributed machine learning. That's all something that you shouldn't actually be interested in, that it doesn't work. What we do actually, we combine two technologies separately. I mean, they work separately, but work together instead of trying to combine both into one product. So that's how you should do this also when it comes to the blockchain. BKRX, for example, that we do as a tool, we support also open source tools. In this case, we support let's say a Jupyter notebook that is a bit more let's say boosted than the basic one, or QA check. That is a tool for writing automated tests with artificial intelligence, with the recognition of the issues on the screen. For example, or met transfer, that my recent project I work on about medical diagnosis. All right, so what is machine learning? What is AI? To everyone who doesn't know, obviously machine learning is not something that is the opposite for deep learning. Deep learning is a subset of machine learning, and machine learning is one of the methods of the implementations actually of AI. There are also other ones. Machine learning is one of it, well, why is it so popular? Because it gives the best results for now. When we will have better quantum computing, quantum computers, probably there will be something different used for implementing artificial intelligence. But for now, that's the one that actually works best. So what's the difference? The difference is in the answers and the rules, right? In the traditional programming, we have rules and data, and we actually get answers, right? Some algorithms. And in machine learning, we get the answers and data, and they actually generate rules. And the rules is called the model. So what kind of models we have? We have we can classify it. I mean, there are different kind of taxonomies. If you read different books, you will find different kind of taxonomies of machine learning methods. And but to simplify that, there are 5 questions that actually you can ask to find out what kind of method it is. So if it's A or B, we talk about classification. If we ask if is this weird, we talk about anomaly detection. If we ask how much, how many, so if we change X, what will be the change to Y, then we talk about regression. And actually, most of the banks, actually banking companies or finance companies, they use linear regression, for example, for, I don't know, 30, 40 years now. And they don't call themselves, I mean, okay, there are some that call themselves AI banks or AI companies, but that's not because they are AI, they use linear regression. That's the only reason in many cases. So how is it organized? Clustering. What should I do next? Reinforcement learning, it's about predicting the next step, right? Like in the video game, for example. So we have 2 types of artificial intelligence. Artificial general intelligence, or AGI, and artificial narrow intelligence, ANI. What's the difference? The difference is that, ANI, so narrow intelligence, is about a specific domain. Let's say skin cancer diagnosis, right? This model is built to recognize cancer, right? Specifically skin cancer or not. I mean, finding out, okay, that's a cancer, that's not a cancer, right? So A or B. In case of general intelligence, that's an approach where actually it's about learning new stuff, right? In the meaning that like if you saw Westworld, for example, that's a good example of an AGI. And if you ask me, do we have an AGI? Do we have AGI models? Well, there are some articles where actually you can find articles about that we have some, but actually not really. I mean, all of the models we have built so far are actually called ANI. Even if we have Siri or I don't know Google Assistant, for example, they could be, let's say, told as a AGI, but actually it's exactly like that. Still, it's about a chatbot, about responding to the customer, right? Not doing something else. So that's the difference between AGI and AI. And so far we have the ANI. Probably we will have some AGI in the future, real AGI, but it's for now I think more. I mean, it's not science fiction anymore, but it's not yet. We are not yet there really. So what's the difference again between AI and machine learning? AI is cool on slides like here, or machine learning is what actually is done in practice using Python or Scala or any other programming language. So what kind of methods we have, just to give you a bit more details, what we will analyze today or what we'll be talking about on the next slides. So we have some simple ones like linear regression. What's the difference between, I mean, what will the weight change when the height of a person change? This is obviously the BMI here. Or logistic regression, right? That actually the slope. I mean, that's the prediction will be is actually can be drawn as such a line here. Or the k-means, where we have clustering, right? In this case, obviously airplanes, or decision tree based on the. I mean, that's an easy one because you can easily interpret it as if statements, right? If the nested if statements here. Then again, obviously in the simple ones, because we have also the more advanced one, more complex ones, like the not decision trees, but also let's say random forest, for example, where we have more trees in it, trees, forest, clear. That actually, if you draw it, it looks like that. Really, so you divide the feature space into smaller sections to have the same objects of the same class in the perfect, obviously, scenario. Or you have SVM, for example, that is also explainable methods where actually you try to find a margin that is the widest one possibly, be of having the support vectors here that are filled once. Or the reinforcement learning where actually you have reward. That's similar to, you know, if you train a dog, right? That's the same way. You give a snack to a dog if the dog do the right thing. If not, obviously you don't punish your dog, but the dog knows that actually doing something wrong will not be. The dog will not get a reward at the end. So it will try to learn behaviors to actually get the rewards, right? That's more or less the same way, but doing using machine learning. Or we have ensemble methods. It's about building many weak classifiers to build a strong one at the end and combine them, for example, like that. Or we have the most popular ones, so the neural networks, where we have many layers. In this case, we have only 3 layers, a very simple network, but in many cases, we have many or even more layers. I mean, we have 5 here, that's an outer encoder, or we have even more. Why the neural networks are so popular now? It's because we have building a larger neural network usually ends with a higher performance. It's not always true, but in general, yes, because of the computation power you need to spend to actually train that. There is a really nice article from 2020, where actually some scientists compare the computer power and the results. That sometimes it's better to actually spend less computer power to get the lower results, but at the end, than building a huge network, there is obviously a correlation between that. And again, neural network ImageNet is a very popular data set that is used to find objects on an image. And as you can see, year by year, the networks are better and better to recognize that. Here, an example of a convolutional neural network, one of the most popular type of neural networks now, to find objects on the images. But we need to go deeper, meaning we can build even deeper network, like here, the inception network. Each of this block here, the blue one, green, red one, yellow one, is a layer. So you can imagine you can have such a network or even bigger one. This is just small part of this layer. So we have the previous layer, the convolution operations here, the max pooling and so on. That's one of these blocks here that you see on the screen. So you can imagine there's a lot of computation here. So in most cases, it means better performance, but obviously it depends on the case that you are investigating. And here is a really nice chart where actually you can see that not the biggest one is the best one, right? But well, it also depends how you connect the layers, what kind of layers you add, what kind of operations are included in each layer. And you can see Inception, for example, version 3 is better than the VGG16. That has more parameters to be set, or even Inception 4 is even better than that, and is much smaller. All right, so this is about buzzwords. Machine learning is obviously not the first buzzword. We had blockchain in the past, data science, we had cloud computing, and so on. Actually, when it comes to machine learning, just machine learning, there are so many buzzwords that are combined. I mean, they are connected somehow. Like, chatbots, for example. A couple of years ago, we heard about chatbots that are so popular, and many people talked that said that actually they will replace many of the jobs will be replaced by chatbots. It didn't have. I mean, it happened to some degree, and some bots are really intelligent, or let's say works well. But actually, when you met a bot, in many cases you see that actually it's not so intelligent, actually more annoying than really useful. So obviously the buzzword, I mean the hype on this buzzword dropped after 2 years. Probably it will happen the same with machine learning and artificial intelligence. Probably will be a bit longer as a buzzword because it's a very wide term. But yeah, but it will happen. I mean, we will probably face the AI winter at some time, like we had in the 80s and 90s. Probably, right? Let's see what happens. Here's also another nice chart of the hype, of the terms that are in the hype when it comes to AI. Like, as you can see, the chatbots in 2019, they were still here on the peak, but now I guess they are somewhere here, right? So if the dot here or the term is more to the right, it starts to be more mature, right? Not hype, but mature. That's also important. Okay, so that was just an introduction. So let me just move to the mistakes. So what kind of the common mistakes and how to avoid that? So one of the first and the most popular, I think, mistake is to use machine learning by any cost. So solve a challenge with machine learning. Please keep in mind that machine learning, that's still it's still kind of a research, meaning that you can spend a lot of money and don't get anything. It's not saying like software development. And in many cases, there are simpler solutions than machine learning to solve a specific case. So please keep that in mind, that it's the hype would not solve your problem, right? It's not a solution for your problem. You need to think that if machine learning is really the one that is the method that will solve the issue. I saw many of such projects where actually they use machine learning, where actually there are there are many easier solutions to solve the specific issue. All right, so let me give you an example. You heard about, let me tell you a story about a girl, a small girl, right, for red cap and the big bad wolf. So the goal here is to deliver a piece of cake and a bottle of wine to the grandma, as you remember from the story from your childhood. But obviously the story is from from the 18th century. So obviously children's and wines, that was fine at that time. So the goal here is how to distinguish between a grandma and a wolf, right? So the little girl, the goal was here to find out if it's a wolf or a grandma, right? So well, in the 18th century, it was quite a difficult probably. Now we could have AI to solve the problem, right? But to go a step further, let's imagine you have not a challenge to distinguish between grandma and wolf. You have a challenge to distinguish between husky dogs and a wolf, right? So to some of you that doesn't know how a husky dog looks like, that's a husky dog and a wolf. Looks for many people very similar to a husky dog, very similar. I mean, they are different, right? But not everyone will see the difference. The difference are not obvious. And there are some researchers that did in the past a research about that. I mean, they have developed an algorithm that it was about to distinguish on images if it's a dog or if it's a husky dog or if it's a wolf, and they reach an accuracy of about 90%. That's a quite high accuracy for finding such objects. But when they explained why actually the decision was made, why it's so classified as a husky dog or a wolf, they received this kind of an image where actually the gray color means no important, and the other pixels here are marked as important for the classification. So you can see here that actually if the dog or if the animal is on snow, it means it's a wolf, and if it's, for example, on a couch, it means it's a husky dog. Why? Because the data set was prepared in this way. Because wolves lives in the wild. I mean, usually. And that's why also the pictures are in the forest, on the snow, and so on. Where actually the husky dogs, the data set is actually, I mean, the images were taken, I don't know, at home, in the garden, in the park, somewhere in the city, most cases, right? So that's the difference. And we have so many cases where actually the data set was not well prepared for the, I mean, not the method, not the machine learning was the problem here, but the data set that was prepared, that there are thousands of such examples. This is just a very simple one. Well, actually this one, and accuracy doesn't mean anything here because it's just wrong. I mean, the whole process is just wrong. And obviously we can overfit. That's another thing that we can do here, depending obviously on the data set. All right. Another thing that is also a quite typical fail, that is also related to the data. It's about the companies that doesn't have any kind of a strategy, AI strategy. What doesn't mean an AI strategy? I met many companies where actually they want to use machine learning, but the data they have is not prepared to really be used. And all of you probably agree with me that actually the data scientist work is actually mostly about 80% related to really data, not really the machine learning work that is done after we prepare the data. And actually to do this in the right way, we need to have kind of a strategy of getting the data, so acquisition, how to store it, right? We should have a drive on automation, many of processes, and also we should have kind of a data roles. I mean roles like here's a data scientist, there's a data engineer, here's a machine learning engineer, and so on and so on. There are different kind of roles. I mean, from the engineering perspective, that are focused on different areas, like the business analyst, for example, is also very important for the AI projects. Another issue, also very popular, is that it's about also connected with hype, but also it's about actually doing something for, let's say, marketing or the PR, not really for something that makes sense for us, that give us an add value to our business. That's popular, less popular now. It was popular, let's say, 1-2 years ago, when actually we had the peak of the machine learning hype. But still, I still see it in some of the projects. Using the proper process, I mean, machine learning, data science, machine learning projects are not exactly same like typical software development. So the process should be treated in a different way. One of the important part of the process is that actually due diligence meeting. And obviously, by due diligence, I don't mean the financial one when you do the diligence of a company, but I mean the one that is related to the machine learning or data science projects. I will tell you more about it in a minute. Some other cases here, you can see here there's an image of a Tesla that just crashed to the against the track here in US. We can if you have the wrong data set, we can overfit, or we can just think that our Tesla that this is actually the landscape, right? So we will drive through and die. So that's not the right thing. That's not the way how we should do that. Build the right team, right? So I mean, for example, Netflix, some time ago, they mentioned about 9 different roles when it comes to the structure of a team. I mean, of a machine learning data science team. And you don't need to have all of these, but it's important to have different kind of roles in the project at the beginning. Obviously, it's not so easy to find such. I mean, good experienced machine learning engineers, data scientists, and so on. So there are different kind of approaches how you can deal with this issue. Like, for example, hiring someone that is experienced in a similar area, especially if you do projects that is actually are in the medical industry. You should have someone that actually is somehow connected. Obviously, you can actually also hire our data business analysts that actually know the domain. But in many cases, it's also important to have someone that actually worked in this industry before, or at least has some experience or knowledge about it. Or you can obviously hire a company that actually will do it for you, obviously. Another thing that is that I see, especially when it comes to the junior engineers, they try to build something that is already there. Meaning, we have many kind of neural network architectures, methods. When you use Keras, PyTorch, or TensorFlow, they are already there. You need to modify it to your case to make it work. But don't try to build it from scratch, especially if you do a POC, because this will just not. I mean, this will might work, but it will take much more time, and that's not something that you don't really need. What you should do, you might use actually some instead of deep learning methods at the beginning, you can use some shallow methods in the first place, especially if you work with some CSV, some table data, or use AutoML or similar project. I mean, the AutoML from Google, but also there are also solutions like AutoKeras, PyTorch, and so on. And again, use proper hardware. I did one mistake where actually I used the GPUs on the cloud to build a NLP model, and I just forgot about it, and it trained for a week on 50 GPUs. The invoice was huge, and the model didn't work. So it's important to use the proper hardware for you. It's not always a good solution to use the cloud solution. Sometimes it's easier to actually build a graphic card like a Tesla one or RTX. I know they are quite expensive now, but still it might be a better solution to buy one or a few to the company to do it there instead of use in the cloud. And if you use the one in the cloud, it might be a better solution to use the TPUs, or the ones that actually are dedicated for training machine learning models instead of typical GPUs, because they are not cheaper. I mean, TPUs are not cheaper, but because they are faster, at the end they will be cheaper. Or yeah, focus on security. That's a nice tweet from Thai Tweetbot. They just did a mistake when it comes to retraining, and they failed on that. That's I think it's a security issue. That Microsoft just, well, they messed up here. They didn't made a good work when it comes to Thai Tweetbot, because it was trained to be on a, let's say it's short in 24 hours. So that it went in a totally wrong way. And there are many actually methods how to avoid that. Right, so sentiment analysis, for example, on the output, on the input, and so on. So there are plenty of methods that should be used here. All right, so give you some examples, some real examples from some of our potential customers that we work with, or customers. Once I approach our customer, a travel company, they came to us asking us for NLP methods. They wanted to build an NLP method, and they asked us to do to use an NLP method for getting some information from emails. And well, we did our research. We find out, well, okay, you can do it with regular expressions instead of a machine learning method or an NLP method. Still, they forced to do it with machine learning or NLP because they obtained our financing from the government for building an NLP method. It was totally wrong, but that's how it works sometimes. Or a bank, they build a POC for 8 months, and they ask us what they are doing wrong. So first of all, we just said, just stop doing it. If you do a POC for 8 months, it means you do it totally wrong on many levels, right? It should take 3 weeks, maybe a month for a POC, not 8 months. There is a lot of money that actually was burned doing nothing. Or we have a chemical company. They actually ask us to help them with machine learning to automate some formula recognition, and obviously we work with them on that, but we figure out that actually not the machine learning method was the problem, but the data they have collected, they need to be cleaned up, and that's in many companies. Clean up the data and extract the features in the first place, instead of force a machine learning method. Or customers, NLP, many companies still don't have knowledge in some areas. In this case, we help the bank to build a retrieval-based chatbot instead of a rule-based. It is a simpler, not really intelligent bot, chatbot in this case. Or a car manufacturer. That's a really nice case, because everything was fine until the deployment. It was done in Germany and it was developed for the German market. I mean, not development for the Chinese market, but was developed like it would be for the German market. When it was deployed to China, it was in China. The managers recognized there is a law issue and it cannot be used. This is one of the cases where actually the due diligence was done wrong, totally wrong. 9 months of development just was burned and done. Actually nothing. Oh, here a security issue, right? Where actually you can easily fool a neural network here on the right without just a picture. Or here an example of Alexa. That's a well-known fail where actually the Alexa said to the person to suicide herself. Very nice. Or here another one, overfit. Nice overfit here. You can recognize on the picture. Or IBM that actually did a really nice model for prescriptions for the drugs and recommendations, and based on the recommendation, the patient died sooner than without it. So they dropped this project. Oh, here you have the Uber one, self-driving car that killed the president. Okay, just going to the last part of my presentation, the AI transformation. There are many steps that actually are part of the process, like assembling data, pre-processing, training, prediction, validation the models. This is how it looks like usually. So we build the model in the training phase and also predict it in the predicting phase. We have also a retraining phase if you want to add some data. Or what is also important is that based on Andrew recommendation, we can divide the AI transformation of a company that's not AI focused into several steps, like building some POCs first, building your AI team, providing some trainings, strategy to the company, and so on. So there are many steps that you should fulfill to really call yourself an AI company. So the process, or the due diligence process, or actually the POC process, should be not the due diligence, the POC process actually. All right, 5 minutes left. I'm almost done. You should first of all divide into tasks. Think about quality metrics, because accuracy is not the best one at all. I mean, there are plenty of other ones, F1 score, specificity, sensitivity, and so on, that are better one. Accuracy doesn't really give you a good information about how good you are. And also divide all of the tasks that you want to do in the POC into kind of a data acquisition, pre-processing, model structuring, quality metrics tasks, right? And obviously perform the due diligence before starting the project. So what's a due diligence project? That's a due diligence meeting. It's a meeting that you should do before you start the project and answer a few questions. So there are two things that you should think about before starting the project. What can be done using our machine learning model, right? And that's a part that actually can the AI expert answer you, or the domain expert that can tell you, oh, that's something that's valuable for your company, right? And just a small part of it, I mean, the orange one here in the middle, are the projects that should be really done. So you should answer 5 questions. First 3 are technical. So is it possible to really do it with machine learning? Second, do we have enough data? Do we have data, this kind of data, to really solve that? And do we have really people to deliver that? Should we hire someone, right? Do we have people who actually know that, the domain, and are able to really deliver that? And from the business point of view, we should ask, will it reduce their costs or increase their revenues? Or will we provide a new service? Structure, as I said, 9 different roles that are mentioned by Netflix, like the business analyst, 3 types of analysts, 3 types of engineers, 3 types of scientists. It doesn't mean you should actually have all of these kind of types of people in your company. I guess 3 is more than enough. All right. So short summary. Just what I would like you to actually take away from my talk is that the due diligence, please do the due diligence before the project starts, especially if you are a startup, right? That's even more important, because the financial point of view of every startup is crucial. It's super important, right? So if you fail here, you'll just fail the whole project. That's bad, right? Obviously. Second, don't use machine learning at any cost. I know I do it for 15 years now, and I saw many projects failing because they use machine learning instead of a method that actually is simpler one, and will give you a 100% accuracy. Another thing is that you should fail fast. I mean, don't build POCs for months. Don't try to force the solution. If it doesn't work after a couple of weeks, if you try it out, it doesn't work, forget about it, drop it, and just move on with a different one. That's all from me.